Question is a math question. It says WXYZ is an isosceles trapezoid whose diagonals cut each other on the right angles at 0 or at O. What is the length of the slanting side of the trapezoid?
Sounds like another me question.
Looks like a you question.
So that's geometry. I'd actually saved this on a tab, but there are a lot of tabs here. So I'm going to do it again.
It's not my fault, I swear.
Even more important on this one, to have this on, like, so you can write on it. Let me just pull it up really quick. All right, I think I got it. So the reason is because you want to be able to draw on these figures so you're not constantly kind of going back and forth with what was written and what you're trying to calculate. So I'm going to show you a quick hint, especially if you're at home doing this. If you look at this figure, it's an isosceles trapezoid. So there are some properties that you would know about this. Some line segments that are going to be congruent, diagonals that are going to be congruent, angles, things like that. As a geometry teacher, I find we kind of overload our students with a lot of properties, conjectures, theorems. It's really hard to memorize all of them. Part of it just comes from practicing with these figures a lot. But I would say if you were at home and you're like, I have no idea where to start, I think the best place to always start is I'm just going to go to Google really quick and look up properties of isosceles trapezoids. And a quick hint, like you have a pretty good example on here, but I like going to Google Images for these things. You always have like some very concise thing going on. I'm actually going to steal this one that popped up first. So what we're going to look at is some information. I'm going to try to minimize this, but here's what I'm going to tell you. You can look at all this information and it will tell you things that are congruent, things like that. So we're going to go here, and I'm pulling this stuff from memory because I do this all day, like every day. So you know, if you want to have that resource handy, it would be helpful. But here's some stuff that we know. We're going to know that in the isosceles trapezoid, these are going to be parallel. But that's not really going to help us with this. What we really want to know, I'm not going to get into all the properties actually because it would be a lot of work or a lot of time. What we need to know is because we're looking for this slant length, and we can look for either one. We're looking for this one. In isosceles trapezoid, these are going to be congruent. So we're looking for those. I'm going to label them with the geometry congruent symbol. In an isosceles trapezoid, we also know that the diagonals are congruent. So all the way from here to here, this is going to be congruent from here to here. There are some congruent angles, but again, that's not really going to help us with this particular problem. With that said, we also know that these two, from here to here, this is congruent to this. And we know that this piece, because these long diagonals are congruent, is congruent to this piece. So kind of taking a step back, when I look at this problem, I look at that 90-degree angle and the fact that it's formed 4 triangles. And when I see these right triangles, I automatically think Pythagorean theorem. And in this case, you're going to be doing it a few times. So here's the thing. We have a right triangle right here. Typically, when you think right triangle, a squared plus b squared equals c squared. If you look at this, we have a 5 as a hypotenuse equals 5 squared. And if you initially look at this, you might think, I have too many variables. Well, that's where this comes in, that we know that these are congruent. So when we know things are congruent, we use the same variable. So in this case, I'm going to call this b, and I'm going to call this b. We know they're the same. So instead of a squared plus b squared, I'm going to say b squared plus b squared is 5 squared. I'm going to do the same thing because I want to find this right here. So I need to use that Pythagorean theorem one more time. I'm going to use it 2 more times, but 1 more time for now. I'm going to call this, I'll call this a, and I'll call this a. And then I'm going to come over here and say a squared plus a squared equals 8 squared. And that's kind of this triangle down here. So once we figure that out, we're going to know this leg, and we're going to know this leg, and that is going to help us find this hypotenuse. So you're going to see we're doing Pythagorean theorem 3 times. So I'm going to simplify this. I'm going to go a little bit quicker because this is just the algebra portion of it. B squared plus b squared is 2b squared. That equals 25. And then we're going to divide each side by 2, and we get b squared equals 25 over 2. And then we're going to do the square root, and we get b equals square root of 25 over 2. I'll share kind of a little tip here. Because we're doing Pythagorean theorem again with this number, there's no reason to like reduce this. There's no reason to put it as a decimal. It actually works out more easily if you leave it like this for now, and you'll see why in a second. So then we come down here and we say a squared plus a squared is 8 squared, so same deal. 2a squared is 64. And then we divide by 2, we get a squared equals 32. And then we get a equals the square root of 32. All right, and then Pythagorean theorem one more time, and then we're done. So same idea, we have 2 legs here. This is one of my legs. This is one of my legs. And I'm looking for this hypotenuse. So I'm going to have square root of 25 over 2, and that's going to be squared, plus the square root of 32 squared. It's going to equal c squared. And then you'll kind of see, if you're good with these kind of radical properties and exponents, that the reason why I left these in radical is because the square root of anything squared is just kind of whatever is inside that radical. So this is going to be 25 over 2 plus the square root of 32 squared is 32 equals c squared. And then this is just some more algebra. So you can choose to either, I don't know, combine fractions, or you can just say this is 12.5 plus 32 equals c squared. And you're going to do this last thing in your calculator. So I got 44.5 equals c squared. So we're going to do the square root of 44.5, and we get what is approximately 6.67, and I'm not sure the units, so I'm just going to call it 6.67 units, because I always want to write some kind of unit, even if I don't know what it is. I just get in the habit of writing units. So that was kind of long. It's just a lot of Pythagorean theorem, and including like with some geometric properties. But hopefully that helped.
Awesome. Yeah, I didn't see that it was Pythagorean theorem until you.
Yeah, always, every time I see a right angle now, because I've been teaching geometry, I'm always like, okay, Pythagorean.
It's got to be that.
Yeah.
Got to be. Well, that's true.
Yeah.